Okay, welcome. This is going to be the summary lecture on the importance of the metals of bronze and steel that you have watched this week. So, gonna go over everything I thought was important to pick up in this, and kind of at the level of detail that I think I would hope you would know after covering these things. So let's jump into that. Okay. So, smelting, casting, forging, bronze and iron. All right. So, the first thing I wanted to start with is this concept of ore, and in particular, the ores that are needed for bronze. Now, when it comes to what ore is, what I was hoping you would pick up is it's just kind of rock. It's rock that has sort of oftentimes an interesting color, but not even always that. But the two main ores that were needed for bronze, and this is one of the things that made bronze unique, is it required two ores, and one, the most common, is this greenish rock, which I believe this is malachite. This is copper ore. Okay. And then the other ore you need for bronze is this one that's kind of darker. This would be tin ore. And this, I believe, is another type of copper ore. Here, this one is some bronze ore with some charcoal. This is one of the processes that's needed when you want to turn ore into metal. You can't just leave it as an entire rock. You have to crush it. And in general, the finer you can crush it, the better. The more effectively it will be eventually turned into metal. Now, the basic process that they did with this ore, we'll talk about that in just a sec here. But the basic process that you did is you got really hot fire, and there were a couple of different ways that they did this. First thing they did is they needed a fuel, and the fuel they used is charcoal. And hopefully the description you got from charcoal, that basically what charcoal is, it's just wood that has been heated in an environment where it can't really burn. And the advantage to do that, like you have a little bit of burning here when they make charcoal, but the idea is that you burn as little of it off as possible, and you're left with all the flammable stuff, all the stuff that burns in wood, but you've kind of cooked away everything that won't burn. In particular, things like water, any sort of impurity. So you're left with just this thing that's just a super important fuel. And basically what they did is they started a fire in the wood, and then you cover it up with dirt. So it's like combusting, but in a lower, sorry, not combusting, it's heating, but without air, so it's not combusting, it's not burning. The other thing they need a bunch of is a bunch of oxygen. So in order to get up to the necessary temperatures to smelt these metals, and what smelting is, it's basically heating the ore. That's really the basic idea. But you need really hot fires to do it. So you need a good fuel, which we had in the charcoal, and you also need charcoal. You also need oxygen, and they did this with these pipes for blowing air. Now we have other ways of doing this, but they did it with just these bamboo air pipes basically. The other thing they did is they again covered it when they were making the ore, so they wouldn't lose heat. Now this would normally block the oxygen, except they would have pipes going in to breathe, or to still be sending oxygen in. And then the last thing they had was what's called the crucible. Oftentimes it's like a clay or a ceramic dish that you put the ore in when you heat it up. And when you heat the ore up, it undergoes a chemical reaction that turns the mineral that has some metal with something else. And it basically what it's doing is it's removing oxygen and turning the mineral into the metal. So that's what's going on. These crucibles are just ceramic dishes, like I was saying. Then what kind of jumped into casting bronze here, showed you some kind of cool pictures of that. But before you get to bronze, what you need to do is you need to smelt the two ores independently. Both the copper ore and the tin ore need to be smelted independently and turned into a metal. And then what you do to make bronze is you mix those two metals together, okay? And that is what makes it an alloy. 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 It is an alloy. Now, a metal alloys can be metals, but not all metals are alloys. Like copper metal would not be an alloy; it would just be, pure copper metal. Bronze is a mixture of. Originally, it was a mixture of tin and copper. Now, that's what I believe all the bronze made in these videos comes from. Today, there are, dozens, if not more, types of bronzes that are alloys of different types of metals. And we'll see actually something similar come up with steel when we talk about that. But basically, the idea was, you melt the tin, you melt the copper, you mix them together. When you pour them, they come out as this metal that is superior to both the tin and the bronze. Okay? So, the bronze it kind of looks like gold. It's not. It's a little bit more white than gold, I guess is how I would describe it. But you can polish it up kind of nicely, and we saw in some of the videos they did this. One of the things that is pointed out here is that when you cast it, and casting it is you melt it and you pour it into a mold to make the shape you want. A lot of times you will get these holes here, and you can see some of them there. Some of them there on the knife. A lot of them look like they've been polished out in this sword, but that's from air bubbles that are present when you pour the mold. So those even on the better bronze tools, a lot of times those air bubbles can't get out. And it's something that we don't see nearly as much when we start looking at iron and steel. We do see it a little bit, and we'll see it in a couple of different spots, but we'll go over that in a bit. Another thing to note about bronze that he said, he brings up this point a couple of times. The tool, it's a significantly harder metal than either of the things we saw tested. So copper's probably the closest. You saw in the demonstration of tin. Tin kind of gets crushed like clay. But bronze is significantly harder, keeps its edge a lot longer, was pretty good for weapons, and for tools. Not such a great construction material. We'll talk about why that's the case when we get to some of the properties. But very cool for weapons, and I do honestly think the color of bronze just is it's a very pretty metal, I think. So that would be bronze. We go on to iron. What we have here, I thought I had. Oh, probably not. Shoot. Okay, looks like apparently some of those pictures of iron ore I thought I included, I actually didn't. That's a mistake. Oh well, but in any event, we usually had a number of different things for iron ore. Now, the main advantage of making iron over bronze, especially initially, was it didn't require multiple ores. If you had access to iron ore, you could basically use it to make iron. Now, the disadvantage is that it's harder to make things from, and you saw that you need a much more advanced setup in order to get the temperatures you need in order to make iron. Now, these are the two samples they initially used to try and make iron. These are both sort of lower quality iron ores that he took from a mine in Minnesota. The better iron ore was that red clay, which was very well. It was basically ore that it's called bog ore, and bacteria kind of turned the iron in the area into they really refined it and made it really fine pieces of iron, which apparently makes for pretty high quality ore. The other disadvantage of iron is, at least initially, the weapons were probably not quite as good as the bronze weapons. We'll see eventually when you make really good iron weapons, they become better than bronze. And you saw that in some of the tests, I'm sure. But initially, until people figured out how to make iron, iron weapons. The bronze weapons were probably superior. It's really when you stumble upon steel and you start making steel weapons that you have superior both weapons and armor. And ultimately, steel is not only good for weapons and armor, as we saw, but it's also a very good construction material as well. So that was iron ore. Now, as we said, you need an even hotter fire if you're going to smelt iron. And the setup they used to smelt the bronze was pretty primitive. They did not need these big, what are called bloomeries, to allow the oxygen in, to get an airflow, to get the burning really going on. The other thing that's needed with iron is it's not just a matter of the heat. You also need to react the iron with some of the elements that are in the charcoal. So you need to have the iron and the charcoal mixed pretty well in there. And as a consequence, what you get a lot of is these this kind of stuff burning off, and that was slag. So these were two of the kind of simpler bloomeries that were used, and then this is a more modern iron furnace that uses propane. Doesn't require as much fuel, so that can be used to melt iron as well. I don't actually think this furnace would be very good for smelting iron, because I don't think it adds the carbon in to have the reaction, which really helps separate the iron from the slag. So this one's probably more for melting and heating the iron than it is for smelting it. But the fire does need to be hotter to smelt iron, which is another sort of difficulty with it. Now what you oftentimes get, for one, the slag will often get liquefied. That's what we're seeing here. We're seeing liquefied slag. And this is another example of smelting. You can see them putting the red iron ore on top of the charcoal. And actually, here's the orange iron ore. I think I put that on the wrong page, but there's the orange iron ore. That when they bake, it becomes more red. That's a tradition, a color more like rust, and rust is sort of the oxidized form of iron. Now what you often will get when you smelt iron is you won't get a liquid metal to come out. You can do that if it gets hot enough, but a lot of times you won't. What instead you'll get is pieces that kind of look like this. And the slag may well liquefy. That's one of the things that does happen. But you get pieces that look like this, and this is often called sponge iron, and it can have various different levels of impurities in it, depending on what's going on there. But it often doesn't completely liquefy, but it does turn the ore into iron. So at this point, the iron can then be worked with a hammer and things like that, which we call forging, which we'll get into that. So that is one of the ways in which it's a little different from bronze, is even after you smelt it, you don't have a liquid that you can just pour into a mold. You have something that you need to work with a hammer. So you need, not to just be able to smelt it, but then to also be able to shape it afterwards. And that's it's a bit more difficult than just pouring it into a mold. Now that is when you work it with a hammer, that is what we call forged iron. And when you forge iron, you can have it turn out a number of different ways. You can really get any different one of the types of iron. You're probably most likely to get something like wrought iron the more you work it. But we'll talk about what wrought iron is in a bit. But one of the things that people found as they continued to work forged iron is that you could eventually get steel. And we saw that in the comparison of the steel and bronze blades video. It was an iron and bronze blade, but really that was a forged iron blade that was a steel blade, not like a cast iron blade, because you did that comparison later, or even a wrought iron blade. And when you got steel weapons, you saw the comparison. They just significantly harder, significantly stronger. A lot of ways those steel weapons became superior to the bronze weapons. But again, you still get to you get to take the sponge iron and you get to work it over. We didn't see a whole they tried to do that with the initial iron they forged, but turns out it wasn't working so well. So they kind of went to just a normal iron bar that they then forged into a sword. So that would be forged iron. Now, cast iron, this is what happens if you get the iron hot enough to melt it and then pour it into the mold. And they did this a couple of times. The sword they made looks kind of more like a knife, really. And you can kind of tell that it's cast because it has some of those air bubbles, kind of like the bronze thing did. And, it's even, you polish it up, it even looks good. But one of the things they know, it's very likely to shatter. Very brittle. And that's one of the things that can happen when you melt iron and then pour it into a mold. And that's casting iron, so thus the name, cast iron. But it's oftentimes very brittle. Now, once you can reliably get very high temperatures, cast iron becomes much more... you can make a lot more of it if you can get really high temperatures in those big crucibles. But and that's why cast iron became a commonly used material in the Industrial Revolution. And eventually, what people learned from cast iron, they could refine the steel making process as well. But in and of itself, cast iron can be kind of brittle. So very likely to shatter. It can be sharp, it can be hard, but very likely to shatter. So not great for in comparison to steel, and definitely not great for weapons. Not great if you're going to be taking a lot of impacts on them. Oh, by the way, I think I forgot to mention that cast iron is most of these types of iron we're talking about, they're basically alloys of steel and carbon. And when you have steel alloyed with carbon, you get different types of iron on this continuum. Cast iron has the highest amount of carbon in it, and you put too much carbon in the alloy, it makes it brittle. You put too little carbon in the alloy, so you basically remove it, so it's pure iron. You get what's called wrought iron. And one of the really nice things about wrought iron is that, in as far as metals go, it's kind of soft. So you saw them be able to shape it into these metals. So a lot of times, wrought iron is a little bit easier to work than steel. And it turns out that basically the way people would eventually get to steel was by working wrought iron over in specific ways. Now, we saw one of the things that you can do with wrought iron is you can twist it into these interesting shapes. You can bang it into interesting shapes if it's hot. We saw that numerous different ways. And then you can treat it and sort of make it harder into steel. And there are a number of different ways you can do that. One way was what they called case hardening. And basically what they did is they made the wrought iron and then surrounded it in some carbon, heated it again, and kind of got the carbon to go into it. And so they had a wrought iron tool that was surrounded by a layer of steel, which made the tool much harder, much stronger. Wrought iron is not particularly hard. It's more flexible, way less brittle than cast iron, but not particularly hard, not like steel. So it doesn't make great weapons. Or even tools, although the tools can still be pretty good because iron is it's still a metal, and it's still a fairly hard metal. Now, when you start getting into steel, basically what this is you're trying to get the carbon content just right, and there are a number of different ways to do this, and steel even goes a little bit beyond that. So there are a bunch of different types of bronzes, there are now a bunch of different types of steels. And the type of steel you get can change depending on how you cool it, what you cool it in, how quickly you cool it, all these kinds of things. It's a fascinating subject, something I've often wanted to know more about. But the main thing you got to understand is that steel it's sort of basic steel is an alloy of iron and carbon, where the carbon content lies somewhere in between wrought iron and cast iron. That's the idea. And steel makes for very good tools, very good weapons, and as we saw, it's even a useful construction material once it can be mass produced. So the last thing I wanted to talk about was ductile metals versus brittle metals, and this it speaks to why steel is such a good construction material, and why bronze, never really would be. Now, what the ductile materials will do is they will allow a certain amount of stretching when they're either being pulled in tension or even when they're being compressed. And you saw this in the tensile test when you had the necking phenomenon, when the thing's being pulled apart and it gets narrow in one spot before it breaks. Whereas with the bronze, it just kind of shatters. Now, we also saw this in the points where the bronze was just plain compressed, where basically the pieces of bronze were smushed together, and then, under too much compression, the bronze actually shattered. And that is why it would not really ever make a good construction material. If it's likely to shatter, then that makes it a big problem, because you can have a catastrophic failure if something you're using for support were to shatter. Whereas steel is significantly less likely to shatter. You suppose you could force it under the right conditions to shatter, but significantly less likely than bronze. So this is why steel is so such a good building material. Now, this other material, we didn't talk much about this. This other material from that video was brass, and it is it is ductile, but it's not a particularly good ductile material. And basically, it doesn't have the right balance. At least it's not good for construction, because it doesn't have the right balance between strength and ductility. So this one, it's way too willing to bend or to stretch in order to make it a good construction material. So that's why steel is kind of the king of construction metals. Okay, so I hope that that makes sense. I hope the process of looking through smelting makes sense, and casting and forging and these different ideas. Thank you for tuning in, and I will see you next time.